Hello and welcome. So, you're curious about coding, but maybe it's always seemed like this big, complex puzzle? Well, you've come to the perfect place. Today, we're going to put that first, most important piece in place and talk about Python, one of the world's most powerful and, honestly, most beginner-friendly programming languages out there.
Have you ever looked at an app on your phone or a cool website and just thought, how in the world does that work? It's like there's this secret language that lets you tell machines what to do, right? Well, what if I told you that you could actually learn to speak it?
And that's exactly where Python comes in. It was literally designed to be simple and easy to read. It's way less about weird symbols and complicated rules, and more about just writing clear, logical instructions. It's the perfect place to start. So, what exactly is this language with the kind of reptilian name? Well, to really get it, we've got to go back to its origin story, which is, surprisingly, pretty quirky.
Okay, so Python's journey kicked off way back in 1990 with its creator, Guido van Rossum. But the real game changer was in 2000 with Python 2.0. That's when the community just exploded. And all that led to 2008, when Python 3.0 came out, and that's the modern, powerful version that is the standard for pretty much everyone today. We're talking about a language that's been growing for over 30 years.
And here's the best part. This fun fact really gets to the spirit of Python. It's not named after a snake. Guido van Rossum was a big fan of the BBC comedy show Monty Python's Flying Circus. He just wanted a name that was short, a little mysterious, and fun. So, Python it was.
All right, enough history, right? The best way to learn is to actually do something. So let's get our hands dirty. We're going to write our very first line of code right now and see it work. Let's do this.
First things first, you need to get Python on your computer. Don't worry, it's super straightforward. Just head over to python.org, grab the latest version, and click through the installer. Once it's done, you can pop open a little program called the command prompt, type the word Python, and hit enter. If you see a version number pop up, you are good to go. So where do you actually write the code? Well, you've got two main choices. On the left, you see something called an IDE. It's basically a special text editor built for coding. But for getting started, I absolutely recommend the option on the right. Google Colab. It runs in your web browser, which means zero setup. You can literally be coding in the next 30 seconds.
And here we are. This is it. This is the traditional first program for every single coder on the planet. Just one simple line, print hello world. You type that, you hit run, and bam, the computer talks back. Congratulations, you just wrote a program. You are officially a programmer. How cool is that? Okay, now that you've written some code, let's talk about how Python organizes all of its amazing features. The best way to think about it is like a giant workshop, just filled with all the tools you could ever need.
This slide breaks down a really core concept, and the analogy makes it super simple. A module in Python is just a single file of code. Think of it as one tool, like a hammer. A package is just a collection of those files, all bundled together. So that's your toolbox.
So why do we have to import these things? Well, imagine if every time you did a small job around the house, you had to carry every single tool you owned. It'd be crazy inefficient, right? Importing is just you telling Python, hey, for this project, I just need the screwdriver and the wrench. It saves a ton of computer memory and keeps everything running smooth.
Now, there are a couple of ways to grab these tools. On the left, you can import the whole toolbox, like import math. This is really safe because you always specify where the tool came from by writing math.py. On the right, you can just pull one specific tool out of the box, like from math import py. This makes your code a little cleaner because you can just use py directly. The only tiny risk is if you have two different toolboxes with a tool that has the same name. It can get confusing. And here's a little pro tip for you. For the really popular toolboxes, the whole programming community has basically agreed on standard nicknames. So instead of typing out Numpy a million times, you just import it as NP. You'll see this convention everywhere once you start looking at Python code. Okay, so we've talked about the tools in your toolbox. Now let's get to the fun part, the blueprints. How do you actually plan out a program to solve a problem? At the core of every single program you've ever used is something called an algorithm. I know, it sounds like a big, scary technical word, but it's really just a recipe. That's it. It's a clear, step-by-step plan for turning your input, your ingredients, into the final dish, your output. And just like a good recipe, a good algorithm needs 5 key things, which you can see right here. It has to take in some ingredients, or inputs. It has to produce a result, the output.
It needs to actually end at some point. That's finiteness. Every step has to be crystal clear or definite, and each instruction has to be something you can actually do, which is effectiveness.
One of the absolute best ways to design your recipe is to just draw it out first. And that's what a flowchart is. It's a visual blueprint that lets you see the whole logic of your program at a glance, using different shapes for different kinds of steps.
The most basic structure is just a simple sequence. You start, you get your numbers, you add them, you show the result, and you're done. The steps just flow one after another in a straight line, no detours. But what if your program needs to make a choice? That's where this diamond shape comes in. A diamond always asks a question. In this case, is number A bigger than number B? If the answer is yes, the program goes one way. If the answer is no, it goes the other way. This simple fork in the road is what makes programs so powerful and dynamic.
And finally, we have repetition, which programmers call a loop. This is for when you need to do the same task over and over. This flowchart here adds up the first 5 numbers. See how the arrow circles back on itself? It adds a number, then it asks the question in the diamond, are we past 5 yet? As long as the answer is no, it loops back and does it again. This is how computers do boring, repetitive stuff so incredibly fast.
And that's really it. In just the last few minutes, you've learned what Python is, how to write your very first command, and the why behind how programs are actually designed. You have all the essential building blocks you need to get started.
So, there's really only one question left. You have the tools, you understand the blueprints, what are you going to build first?